Thank you. Okay, there we go. So, Renuka, I'm part of Network Infrastructure Group at Meta. And this particular presentation today is slightly different than what you have been probably looking at in terms of topics. So, we are switching to the telco network now, and we are talking about OpenRAN. And probably some of you might be familiar about OpenRAN, but let's give you a little bit of context as well. But this program, which is called Evenstar, this was basically to accelerate the adoption of OpenRAN into the telecom network. And what I'm talking today about is the contribution that Meta had made into OCP, and we are excited to bring that IP into OCP and looking forward to kind of getting this OCP community to take it forward along with support from Meta and some of the partners in the telco community itself. So it's a short overview of Evenstar. Evenstar was a name given, no context to other Evenstar movies or anything like that. This was more to kind of set the trend of how we can bring disaggregated modular solutions for the radio network. And this is about a reference design. It includes the whole reference design, hardware and software, along with it, the test scripts, and supports the telecom networks for deployments of 4G as well as 5G. And it is a base design which can be then enhanced to add in whatever comes next in the telecom network. So it could be an evolution to, say, additional features like massive MIMO, or take it to 6G and whatnot. And those who are familiar with the RAN side or the radio access network side of things, the standards bodies include 3GPP as well as ORAN Alliance, and this solution is very much compliant to those standards. And so what we have done is we have taken the standard architecture from ORAN Alliance, and then we have collaborated with some adjacent organizations like TIP, and with that we have created a robust design which is modular as well as very much focused on bringing the overall cost down, and gives the flexibility, and we'll talk about the flexibility part in the context of OpenRAN a little bit more on the next few slides. And so again, going back to RAN, RAN is the radio access network or the base station part of your telecom network, always considered as the most complex part. It has been traditionally designed by some bigger vendors and always kind of coming in an integrated form, which is very, very difficult to, you can say, disaggregate and bring in innovation into. And so with OpenRAN, the concept was to separate out the parts of that RAN in such a way that you can kind of innovate on each part and bring the best of each one to a disaggregated RAN solution. And so that's what this OpenRAN concept is about. And this came to concept with the problem statement from the telecom operators who were saying that we would like to see, we have always taken a monolithic RAN from our vendor partners, but now we would like to see under the hood and see how we can probably take the piece parts apart across standard APIs and interfaces and be able to kind of upgrade, evolve, and innovate on each of the components separately so that we have more flexibility to bring in, say, solutions from multiple different partners, and also have flexibility to kind of mix and match the best possible components. So with that idea, OpenRAN was started a couple years back, and now it's like a movement, and that movement is anchored on 3 key pointers, which are about having a more sustainable supply chain. So again, going back to the point of traditionally it was built by a very small number of vendor partners and not much of optionality there. So with OpenRAN, you open it up to big and small players who can build different components of RAN, and thus can give a supply chain which is more flexible and breaks that vendor lock-in, they used to call it. And so that just makes it more advanced for the operators or the CSPs in terms of how they upgrade and deploy their networks. The second part is obviously because it's a mix and match of different components which are coming off the shelf, it gives you better TCO over the time, and that's the second point is about, which is again super important given that RAN is always complex, very expensive, and has very many different, you can say, areas based on the type of deployments you have. And then increased innovation, again, because you have different components separated out, you have a software-based architecture going on top of it to add features, all the way from the basic features to the advanced ones with AI/ML. The innovation pace increases as you disaggregate the RAN. And so that was the overall concept of OpenRAN, and on that, Evenstar reference design is pretty much based off of that. The contribution itself, that program focused on accelerating deployments, because we thought that by bringing in a set of partners together and innovating on that radio design, you're giving the community a better option to kind of, or a better platform to kind of bring in more of their best of the characteristics of that hardware itself. And so the objective here was to take all of that Meta had built with, I would say, about 2.5 years of R&D and bring it into OCP. And this whole design includes not only the design files and everything that we had kind of built and developed in-house, it also brings the adjacent test scripts and the environment in which you can test and take it forward. So again, I think the part to reiterate here will be that it's standards-based, it has the latest requirements from the operators built into it. The design is all available in the form of what we had done with the focus of reducing the overall bill of material of the radio, and also with the concept of keeping it compliant to the ORAN 7.2 interface specifications and supporting the 4G and 5G deployments, which are the current deployments going on in the network. We pretty much talked about this part. So again, going with the theme of OpenRAN, Evenstar differentiates with its modular design. Again, we are looking under the hood, so you're not kind of buying a black box in terms of a RAN solution, but you're rather looking at each and every component, being able to select the exact SKUs and parts and pieces that you think are the best of the breed, and you're able to mix and match them to come up with the final design, which is not only compact from a weight and volume perspective, but also is open and disaggregated so that you can kind of build additional features on top of it. So that's the concept, which is very revolutionary, we would say, because nobody had opened up a radio design before, and this is the first time, and it comes to OCP, and so that's the part where we are now looking at the community to kind of take it forward, build multiple different SKUs. And again, going back to how the RAN is deployed, you can relate to it. There are different types of base stations depending on the type of deployment. So you're looking at the big macro base stations all the way up to the mid-size to the indoor solutions. And each one of them differ in terms of their characteristics, in terms of their capacity, the configuration, and so on. But the base design is such that it can kind of take that initial concept and give you a way to build SKUs for different spectrum allocations in the world, different type of deployments, and so on. And so that's the beauty of it, that base spec is taken into account with the initial requirements coming from the global operator set, and then gives you that optionality to again kind of innovate on different types of deployment scenarios. What is included? So those who are familiar with the radio design, it includes all the components of it. Again, our objective was to be able to have those components in a way that they fit into a very compact bill of material. So cost was a factor, as well as the design overall was the factor in terms of what can we improve from what is available today in the market. So it includes all the components. The files for all of them are available on GitHub, so I'll just list those down also on the slides if you happen to download later. But yes, the power amplifier module, the PSU, and then the overall board for the hardware, everything about the filter, the mechanical design. So all these components, again, were one by one taken into account. We looked at what is available in the market. We looked at what we could be optimizing in each one of them, again, keeping into account how the overall design will look. And the design itself supports today a dual band radio. It can also be used to reband to multiple different types of radios, single or dual band. And then again, the way the RAN gets deployed, the dual band is very efficient in terms of saving space at the location and so on. But there is also a demand for single band high power solutions as well. So all those different combinations can be kind of derived off of this design. Sorry about this. Okay, so the dual band architecture again is shown if you are here today and tomorrow on the floor. In the experience center, we are showcasing this hardware, and it's available to touch and feel, look at it closely, and also if you have any further questions on the design itself, we will be able to kind of answer those there. So do come visit the experience center, take a look at the design, let us know if you would like to set up any follow-up calls with our experts, and we can talk more about who are the partners today in the industry who have taken this design and started their own build of possible solutions, and which are already kind of in engagement with different telecom operators. So we can have that discussion, and we can kind of get you a head start in terms of your own development if you're interested in it. This is just a snapshot of the GitHub location where the files are available today. You can go connect and take a look, download the files, read the README, and post the questions. We would also be possibly setting up regular sync-up meetings in that telco group so that we can take further discussions there. And we can, again, idea is to gather the community and work on actually taking this reference design into a productized version of our use and take them into the supply chain for the global operators. And I think some of you are familiar with this OCP process itself, which will be replicated here. So we are looking for leading partners who can take ownership of this particular base contribution and take leadership in that telco work group and provide additional support, and not only for themselves but also for the OCP community members who will be interested in taking this design and building off of it. So we would be look out for additional kind of engagement opportunities. We will be looking at going and market sizing, because it's important to understand what the demand side is and then decide what type of SKUs or what type of solutions should be built with this base design. We will be also doing some awareness campaigns, so take a active role if you are interested in those as well. And as everything else is done in OCP, this will be a community-led roadmap. So what you see on the left-hand side is where we have started with the base design. And then we are expecting that we will, in the next few months, kind of come to a roadmap alignment of what is the next SKU set that we could be building off of it. So some examples of building an outdoor RU, or building even an indoor RU, which could be supporting the small cell type of scenarios, and then taking these forward into the actual manufacturing ODM kind of pipeline. So yes, that is pretty much it. To summarize again, this is a RU reference design compliant to 4G and 5G networks. It is available today, all the files into OCP. We have started a new working group there. Do join it, and the idea is to innovate and build multiple different SKUs off of it, supporting different type of network deployments. This is a high-level timeline. We are kind of kicking it off now, and then we expect to complete the next set of specifications as we go into the next year, and then almost showing a timeline of how we could be having the productized versions by the time the next OCP Global Summit kicks in. And again, the Experience Center has the hardware prototype available and is on display. Thank you so much. And please let us know if any further questions.
All right.